Hi, my name is Alex McQuaid. I'll be presenting on mechanical properties and degradation of porous PLA log pile scaffolds for Group 8. The first section of the poster is the introduction. PLA is a synthetic polymer widely used for fused deposition modeling. In comparison with synthetic polymers, PLA shows better mechanical strength and good biocompatibility, which makes it a good candidate for material for bone tissue engineering. Using FDM, it can be 3D printed into pore scaffolds, which aims to recreate the 3D structure and mechanical properties of the bone ECM. This study aimed to investigate the efficiency of PLA for bone tissue engineering through identification of mechanical and degradation properties. The objectives are shown in this poster below. Some of these are to create and fabricate PLA pore scaffolds using Autodesk Fusion 360 and Ultimator 3.0. Another objective is compare the mechanical properties of pore scaffolds with solid scaffolds, along with other objectives shown below. The materials and methods section of this poster. There are various aspects to this project. These were to create a log pile scaffold CAD model of the scaffold using Autodesk Fusion 360. It was also to 3D print the model using an Ultimator 3.0 3D printer. Mechanically test the scaffolds under compressive loads, obtain compressive moduli, perform an accelerated degradation study to analyze the change in mass and change in morphology of the scaffold as it degrades. For each test performed, a scaffold of solid PLA was used for control. Mechanical testing was performed using a biaxial Zwick mechanical tester. The accelerated degradation study was performed by immersing the scaffolds into NaOH at 45 degrees Celsius solution for a 7-day period. The results on the right-hand side of this poster. From the experiments data for the compressive moduli of both scaffolds, the percentage mass degradation of morphological changes in the log pile area, strut width and pore width were extracted and can be seen in the figures on the right. The data shows there is significant difference in the compressive moduli between the solid and log pile scaffolds with a p-value of less than 0.01. The average log pile modulus was 71.95 megapascals and the average solid modulus was 195 megapascals. During the degradation study, the log pile scaffolds showed significant mass loss with 63.5% mass loss in comparison with the solid scaffolds showing only a 48% loss of mass. Both the strut width and the pore width showed a statistically significant increase in size post-degradation, with the average pore increasing in the size by 64% and the average strut changing in size by 6.2%. The percentage area of the log pile scaffolds covered in PLA showed no sufficient change in the degradation. The change in area PLA post-degradation was less than 2%. The conclusion section of the poster. From the results, it was concluded that porosity has a significant impact on the scaffold mechanical strength. Porosity influences the degradation rate of the PLA. This is most likely due to the increased surface area of the log pile scaffolds. The large change in mass but insignificant change in PLA area suggests that the scaffold undergoes bulk erosion. Analysis of the change in the strut and pore width showed conflicting results. This may be due to the limited sample size. In order to get more accurate data, a large sample size may be required. Indications of bulk erosion suggest that the scaffold is not suited to load-bearing applications. Thank you for listening to the presentation made by myself, Alex McQuaid, for Group 8, and thank you very much.